Hello, everybody. Welcome back. Let's continue with our OpenGL programming using OpenTK and C#. So here's where we left off. We had just created our vertex buffer, our index buffer, and our vertex array classes. Today, we've actually got a lot to talk about. I want to take all of our shader code and compile that into a shader program. So again, the source code is now available. I'm going to have a link in the description below. And so let's go ahead and start coding. So one thing I noticed from last time was my index buffer. I forgot to implement the finalizer or the destructor. This will be an index buffer, and all it's going to do is call dispose. Okay, so that's all. I just want to have that in there from last time. All right, so let's go ahead and implement our shader class. I'm going to go back to the game class here. Here's our shader program handle, and if I scroll down here, here's the onload function. Here's our vertex shader code, our pixel shader code, and then we have all of our shader program implementation right here. So we compile the vertex shader, we compile the pixel shader, and then we link the program and delete the shader handles. Okay, so we're going to take all of that code and let's wrap it up into a class. In our project, I'm going to add a new class. I'm going to call this shader program. This is going to be a sealed public class, and I do want to implement disposable. We need to bring in the namespace for OpenGL, so that'll be OpenTK, and it's graphics OpenGL. So real quick, I'm just going to set up the disposable. Here's our constructor. Let's make sure dispose is set to false, and real quick, I'll just write the dispose code right here. Okay, there's the basic code to get everything disposed of correctly, and we need to call dispose inside the finalizer. Now, the first thing I'm going to do is actually grab all of the code from the main game class, all of this shader code down to where we delete the shaders. I'm going to cut all of that out of here. We're actually going to keep the vertex shader and pixel shader code right here because we're going to pass those as parameters to our shader program class. So back here in the shader program, inside the constructor, I'm just going to paste all of that code back right in here. So for parameters, let's pass in the vertex shader code and the pixel shader code. Inside our shader program, we do need a shader program handle. So let's make a read-only field. This is going to be an integer, and this is going to be our shader program handle. Just like we had a handle in our game class, I'm going to make one here. And if I scroll down, so I do make, anytime it's a public read-only field like this, I do make the first letter a capital. So I'm just going to scroll down and change all of these to a capital S for the shader program handle. Let me go ahead and make sure everything gets disposed of here in our dispose function. And that's right now, that's just our shader program handle. So I'm going to go back to the game class and scroll down. Here's where we unload everything. Let me cut out the delete shader code. And we're going to pass that into our dispose function. Give that a capital S. And then inside our game class, that looks really good. Back in our game class, so up here at the top, instead of having a shader program handle, let's go ahead and make a shader program. And then down here, inside of our, right after our shader code, our pixel and vertex shader, let's go ahead and create the program. And then we just have to pass it the shader code. All right, so here we're using the program. We need to give it the handle. So that's going to come from our shader program, and we're going to give it the handle. Same thing right here inside of our, so we're getting the uniform location. We need to give it the program handle. And so now down inside of our render frame, we need to give it the handle here as well. Okay, and I think we're pretty much back to where we were before. Yeah, okay, so nothing's changed there. Now we're going to go back to the shader program and we're going to modify the code a little bit to make it a little bit easier to read, but also give us the ability to save uniforms or to save information about the uniforms and then set the uniform information. So inside of our shader program, I actually want to save the handle to our vertex and pixel shader. This compile step, I'm going to wrap this into their own individual function. So I want to have a function for compiling vertex shader and then a function for compiling a pixel shader. So let me write those functions down here. So just down at the bottom of our shader program class, let's make some static functions. These are going to return a Boolean value, and I'm going to call this compile vertex shader. And we're going to pass in the code that we want to compile. So if it's successful at compiling the shader, it's going to return true. If it's not successful, it's going to return false. So we're going to pass out an integer, which is the shader program, or the this is going to be the vertex shader handle. And then I also want to pass out a string that's the error message. Okay, so if there was an error, let's just pass out the error there. I'm just going to go back up here to our shader code, and let's go ahead and cut out the vertex shader compilation step. and we're going to paste it right down in here. The vertex shader handle we're already specifying as an integer, as an out parameter here, so we don't need to specify the integer right there. So that's the vertex shader handle. If we get to this point and the vertex shader info is not empty, that means there was an error. So we're going to return false here, indicating that this did not compile correctly. And then the error message, I'm just going to set to the vertex shader info so we can find out what it was. So the error, if there was no error, we're just going to return true. Now I think, oh yeah, it's looking for a default value for our error message. So just at the top here, let's just tell the error message that it is an empty string. And, oh, got to spell string correctly there. Okay, so there's our compile vertex shader. Let's go back up to our shader program constructor. And let's go ahead and call that function. We're going to compile the program. So from the shader program, let's compile the vertex shader. We're going to give it the code. So that's just the vertex shader code. Let's pass out a handle to our vertex shader. So really what I want to do here is I'm going to have a field inside of our shader program for the vertex shader handle. So let's make a vertex shader handle. And then if there was an error message, let's just pass it out right here. I'll just call it vertex shader compile error. I want to make sure this actually succeeded. So we're going to check to see if this is false. So if the compile shader is false, let's go ahead and throw a new exception. So I'll just call that an argument exception. And we're just going to give it the shader compile error message right there. Okay, so we compile the vertex shader. I want to do the same thing for the pixel shader. Let's go down here. Let's make a new function. This is going to be a return bool, just like the other one. And I'm just going to write this real quick. It's basically going to match exactly like the other one, except for this is going to return a pixel shader handle instead of a vertex shader handle. All right, I'm going to scroll up here. Let's cut out this code and put it into our compilation function. Okay, so the pixel, we're setting the pixel shader handle right there. This needs to be specified as an integer. So this will pass out an integer to a pixel shader handle. All right, we check to make sure there's no errors. Let's return false if pixel shader info has an error. And then right here, the error message is going to be the vertex shader info. Finally, return true because there was no error. Oh, and sorry, this is not vertex shader info. This should be pixel shader info. And then we need to give error message a default value. All right, we're going to do the same thing up here in our constructor. We're going to compile the pixel shader now. So I'm just going to copy that, and let's just change all of this to pixel shader code. We're going to send out a pixel shader compile error, and then if there was an error, let's go ahead and throw an exception with the pixel shader compile error. All right, up here in our fields, we need to make a handle for the pixel shader. Okay, so that'll make sure our pixel shader and vertex shader get compiled correctly. Oh, and actually, right here, I have vertex shader and I have vertex shader again. So this needs to be the pixel shader code. So copying and pasting, one of the dangers of copying and pasting, right, is if you don't change every single value correctly to what it needs to be, you might end up with an error. That could have easily given us a bug in our code. Okay, and so finally I want to wrap all of this part right here into its own function. So I'm going to make a function called create and link program. So it's going to be static again, just like these functions. It's going to pass out an integer that is the program. And we just need to pass in the handles to the vertex shader and pixel shader code. Okay, and so I can just take this code. Actually, I'm going to leave the delete shader stuff right there because I'm going to put that into the dispose function. But the rest of this, let's just cut this out and we're going to put it down in this function. Okay, so we're going to have an integer result that is the shader program handle. Is going to create the program. We have the shader program handle. Okay, so I'm just going to change all of these to a lowercase s and make sure that they are local. These are local integers that refer to this integer, not the one inside the class. So what we're doing here is we create the program, we attach the two shaders to the program, we link the program, then we detach the shaders from the program. Okay, and then all we have to do is return that reference to the shader program handle, and that'll take care of that. And so up here, let's just set the shader program handle, and we're going to create the program. Okay, and this delete shader code here, let's go ahead and cut that out. I'm going to put that in our dispose function right there, and so that'll make sure the shaders get cleaned up. Oh, and this needs to be the reference to our class shader handle. Okay, there we go. So everything should get disposed of correctly there. Let's take a look at our code. So you can see our constructor is a lot cleaner now. We compile the shader. We compile the vertex and pixel shader, and then we create and link the program. And if I run this, everything should be exactly... Oh, okay, there's an error. Let's take a look at it. Looks like I forgot. I didn't put a semicolon there. Let's compile it now, and let's make sure everything works correctly. And again, it looks just like we did before. I want to get a list of all of the uniforms that are in the shader. OpenGL has functions that allow us to ask the graphics card or ask the program, what uniforms does this program have? Okay, what are the names? What type are they? What are their location? And that's information that I need to store so I can use it later. So let's go ahead and I might want to do that for Vertex attributes as well. So I'm going to make a place to store the information, and then we'll talk about how do we actually get the information. So right above our class here for our shader program, I'm going to make a couple of read-only structs, and we're just going to store information here. Now I'm going to call this the first one I'm going to call the shader uniform. The first thing we want to do is store the name of the uniform. We want the location of the uniform. And then the last thing we want to get is the actual type. So this is called an active uniform type. And the type will indicate what is this? Is it a floating point? Is it a vector? Is it a matrix? Okay, and it has a bunch of different types that it could possibly be. Finally, just a constructor to save the information to the struct. I'd also like to get vertex attribute information as well. So I'm going to do the same thing here, except for this is going to be for vertex attributes. And let me just fill this out real quick. Everything's going to be exactly the same, except for the active uniform type is going to be an active attrib type. Okay, so now we have a place to store all of our uniform information and vertex attribute information. Let's go ahead and talk about how we retrieve that information. And so I think what I want to do is actually make a couple of functions that will do that. Let's see. Yeah, we'll just scroll down to the bottom here. This is going to be static, and it's going to return a list of shader uniforms. Okay, and I'm just going to call this create uniform list. The only thing we need to do is pass in the program handle. So OpenGL has a way of getting information from the shader program, and that's a function called get program. And then here's all the things we could ask it about. What we want is the active uniforms. And then we're just going to pass out an integer, and that's going to be the uniform count. Now, once we have the count, we can create this uniform array that we're going to return here. So get uniform list is going to return a shader uniform array that has information about all the uniforms that this program has. Let's make this uniform list. All right, and the size is just going to be the uniform count returned. Now, the uniform count could be 0, and that's fine. If it is 0, it's just going to return an array that has a length of 0. But all we have to do now to get the uniform information is loop through all of the uniforms. And then OpenGL has another function called get active uniform. And this is going to allow us to get information about this uniform. So the first thing it wants is the actual program handle. The index is just this index in the uniform count, this for loop that we're doing. So we're just going to pass in I. Now the buffer size, this says it specifies the maximum number of characters OpenGL is allowed to write to the character buffer indicated by name. Okay, so this function at the end is going to pass out a name, and we're telling it what's the maximum number of characters that we want to allow a name to have. So I'm just going to give it 256, saying like the very maximum number of characters a name is going to have is 256. The length is something we don't actually care about. That's just the length of the actual name itself. So I'm just going to pass out nothing. The size we don't care about as well, so I'm going to pass out nothing there. We do want the active uniform type. We're going to save that information. And then finally, we do want the name, so we're going to pass that out there. So let's go ahead and create our, or let's add this uniform information to our shader uniforms list. The uniforms at I is going to be equal to a new shader uniform. Let's see, we give it the name. The location we don't know quite yet. We'll get that here in a second, but we do know the type. Okay, so let's go ahead and get the location. And then finally the name. Okay, and now that we have that, we can pass that location right into our uniforms list. Oh, and actually shader program handle should not be capitalized. It should be lowercase. I need to actually create the location. So I didn't actually create the location integer, so location will be equal to that function there. And then this type here, I forgot to pass that as an out parameter. So then we have the type there. Now we have all of the uniform information. I can go ahead and return that list right here. And that function is complete. So I'm going to do the same thing for the vertex attributes as well, but let's go ahead and go to our constructor, and Let's make a uniform field for our shader program class. So this is going to be, these are going to be private read-only arrays. And this is going to be a shader uniform array, and I'm just going to call this uniforms. And then I can get all the uniform information by calling that class. So this will be the shader program. And we want to create the uniform list and pass in the program handle. So there we go. So now we should have a list of all the uniforms in the program. I'm going to do the same thing really quick for all the Vertex attributes. And it's going to look almost identical. It's just instead of shader uniforms, we're going to be using shader attributes. So I'm just going to write this code real quick. So let's make an attributes array. We need to make the function here for getting all of the shader or all the Vertex attributes. So I'm actually just going to copy this code here for getting the uniform array, or the uniform list. So this is going to return shader attribute array. I'm going to call this create attribute list. Okay, the shader program handle is going to be fine. Now in the get program function, we want to now get the attributes. Instead of uniform count, this is going to return the attribute count. Now, instead of a shader uniform array, this is going to be a shader attribute array. And I'm going to call this attributes instead of uniforms. Same thing here. This will be the attributes. And then we're going to return the attributes. So let's make sure this code is all right. So we're getting the active uniform. We actually want to get the active attribute now. Now it's passing out a uniform type. We want this to actually be the active attrib type. Okay, the location, instead of get uniform location, this is going to be get attribute location. And then instead of setting a new uniform here, a shader uniform, this is going to be a shader attribute. So that should get all of the shader attributes. Let's go back up to our constructor, and we're going to set the uniforms. Actually, we're going to set the attributes list to whatever we get from the create attribute list function. The constructor should be all complete. In fact, let's go ahead and debug this and pause the execution right here at the end of the constructor. And let's make sure the values we're getting look correct. Okay, so now I can look at these uniforms. All right, so the uniforms has one item in it. The name is the viewport size, the location is 0, and it's saying it is a vector 2. So that looks correct. Let's look at the attributes. There are two attributes. The first one is a color, and that's a vector 4. It's at location 1. And then the second one is at location 0. That's a position, and that is a vector 2. All right, so that looks all perfectly correct. And if we continue execution, it looks exactly like it did before. To kind of wrap this whole thing up, I want to be able to retrieve this uniform and attribute list information. But more importantly, I want to be able to set the uniforms or send information to the uniforms on the graphics card or in the shader program. So let's scroll down here. So here's all our static functions. I'm going to leave these static functions here at the bottom. I want a couple of functions that allow us to get the shader uniform list and the shader attribute list, but I don't want to return these lists directly because I don't want this data to be modifiable. So I'm going to make a function, and it's going to call this, it's going to return a shader uniform list or array. I'm going to call this get uniform list. We're just going to make a copy of these uniforms and attributes and return that. Okay, let me quickly do the same thing for the shader attributes, or the Vertex shader attributes. All right, so now we can get the list of the uniforms and attributes. Okay, so last thing I want to do is actually make a way to set the uniforms. So I'm going to make a function that is void, and we call this set uniform. And we're going to set the uniform based on the name. So we're going to provide the name of the uniform we want to set, and then let's provide the value of the uniform we want to set. So in this case, it's going to be a floating point value, but it could be a lot of different things. It could be an integer, it could be a Boolean, it could be a vector, it could be some kind of matrix. So for every type of uniform we want to set, we have to have a set uniform function for that type. Okay, so we're going to start out with floating point and then also implement a vector 2 version as well. All right, so now in order to set the uniform, I actually have to get the location of the uniform, and I'm going to retrieve that location using this name. So we're going to retrieve it using the name. And so I'm going to make some private functions here that will allow me to get a uniform, or to get uniform information. So this is going to return a Boolean indicating whether we could find that name or not. And so this function is just going to loop through all of the shader uniforms. All right, let's go ahead and get the uniform. And then we're just going to compare the names. If not, it'll keep looping. And if it gets to the end of the loop, that means we have not found this name, and so we're going to return false. The only thing we need to do is actually set uniform to some default value. So right here, let's just set uniform to a default shader uniform. So now we can get the uniform based on its name. Inside our set uniform class, we need to get the actual uniform. So let's try and get the uniform with that name. We're going to get the shader uniform with that name and pass out the shader uniform. Okay, if it couldn't find it, I'm just going to throw a new argument exception. Okay, and the next thing I want to do is actually get the type of this uniform. So let's make sure the uniform type is equal to a float. Because we're passing in a float here, I need to make sure that this actual type of this uniform is a floating point value. If not, we're going to throw a new argument exception as well. And so we're just going to set the information right here. And so let me go back to our game class. Right here is where we set the viewport size. I'm going to copy that. And let's go ahead and use that as a template for what we're going to do. So we're going to use the program. I don't need to get uniform location anymore because we did that step right here. So I'm going to get rid of that line. And then for the set uniform, this is going to be uniform 1 because it's one single floating point value. The location is going to be the uniform location. And then right here, we're instead of passing in those viewport values, we're just going to pass in the value v1, and then we should be done. I actually want to create one more function, one more set uniform function, and eventually we're going to have more. We'll probably have one for setting matrix values or different types of vectors as well. The next I want to do is actually set uniform for 2 floating point values or vector 2. So I'm going to have a float for v1 and v2. We're going to make sure the active uniform type is a float vector 2 to match what we're doing here. And then this is going to be a uniform 2, and we're going to pass in v1 and v2. Let's go back to our game class. And I'm actually going to run this to make sure it compiles correctly. Okay, everything looks exactly the same. I want to change some things and actually use our shader. So I can go in here, and instead of all of this code right here, let's go ahead and use our set uniform function. From our shader program, we can set uniform. The name is actually this viewport size. So I'm going to grab that and put it right in here. So there's our viewport size, and then we can just give it the value. And this is going to be 2 floating point values. And I'm just going to copy the data we were using before. And then this viewport at index 3, let's copy that and put it right in there. And so now I should be able to get rid of all this code. And so we're just setting the uniform with that function. All right, let's see that. Let's run this and make sure it works. That didn't work, and it's because I'm actually doing this comparison wrong. I want to check to see if the type does not equal a float vector 2, and then if it doesn't, it's not correct. And then the uniform type is not a float vec2. So the comparison I was actually doing opposite, and I need to change that up here in this one as well. So this comparison should be does not equal. So if it doesn't equal the correct type, then we're going to throw an exception. All right, let's run that. Perfect. Okay, so we are setting the values, and that looks really good. It's turning out exactly the same. So in order to kind of indicate how this works and show how easily we can change things, I'm going to actually add a new uniform to our Vertex shader code. We have the viewport size, but I want to add a new uniform that's going to change the colors of the boxes we're drawing. Okay, and so this is going to be a float. I'm going to call this the color ratio or actually the color factor. Okay, and what I want to do is I want to change the color so it kind of fades from black to its original color and then back to black. So we're going to see the colors kind of fading in and out from their original color to black and then back to the original color. And all I have to do here is ensure that the color factor is a value between 0 and 1, and then multiply the color that we're passing into the vertex by the color factor. And then I can set this to be anything I want. If the color factor is 1, that means the box is going to be its original color. If the color factor is 0, it's going to be all black. And so I'm just going to write a function that'll kind of cycle between full color and black. All right, so now at the top of my code, let's go ahead and create the color factor. So I'm going to have a floating point that is the color factor. I'm going to set that to 1 originally. And then I also want the amount of change that the color factor is going to occur every update. So let's call this delta color factor. And I'm going to set that to We want this to be pretty small because we're updating at 60 frames per second, I believe. The amount of change is going to be 1 divided by, let's just do 240. Every update is going to change by that fraction inside of our update function. Oh, and actually, let's compile this and make sure it runs correctly. So you can see everything's black right now, and that's because the default value for color factor is actually not being set right now. We're not setting the color factor yet, so it's just defaulting to black, and so it's multiplying everything by 0. Let's go ahead and set that uniform right here. So the shader program, we're going to set the uniform. This will be the color factor. And let's go ahead and set that to whatever the color factor we have here is. Okay, so now it should be back to 1. Okay, so we're at full color now. Let's scroll down here. Inside of the update function, I want to increment the color factor by the delta color factor. So what we'll do here is take the color factor and we're going to increment that by the delta color factor. So let's just put a couple of if statements here. If the actual color factor is greater than or equal to 1, I want to set the color factor to 1. And then I want to reverse the amount of change on the delta factor. Instead of incrementing by a positive amount, I want to increment by a negative amount. So what I'm going to do is just reverse the sign by a -1. And then do the same thing if it's, so if the color factor is less than or equal to 0, we increment the color factor. We check to make sure it's within a valid range and then reverse the sign if it's necessary. And then finally, so right under here, we can just go ahead and set our uniform. So let's get our shader program and we're going to set the uniform and we're going to set it to whatever the color factor is. So let's go ahead and see what that looks like. Okay, there we go. So that is our shader program. And that's how we're going to be able to create programs really easily. All we have to do now is send it the shader code. The shader program class will take care of creating all of the shader code for us. It'll get all the uniform information. And then anytime we want to set values of uniforms, we just have to set up a set uniform function that will work with that type of values. So that is the shader program class.